All right, so in this last video, we're just going to go over deciding what type of test we're going to use. Chi-square test for independence, homogeneity, or goodness of fit. A manufacturer packs a prize in each box of its cereal and claims the probability of getting the prize as follows. To see if the company's claim is accurate, a consumer group randomly selects 1,020 boxes of this product and obtains the following data. Does the data support the company at the 5% level claim? Is this a chi-square test for goodness of fit, independence, or homogeneity? Let's take a look and see what we're given. Notice that we are actually given the probability that we're going to get a ring, a keychain, a puzzle, a pen, or a flashlight. Then we're given the actual counts for a ring, a keychain, a puzzle, a pen, for a flashlight. In this case, since we are checking to see if the two counts match each other, we're going to use a chi-square goodness of fit test. We're checking to see if the claim made by the company fits what the consumers actually get. Now, just be careful. When you write your null alternative here, we're never checking to see if the observed counts match the expected counts. We're just checking to see if the claim made by the company fits what the company or the consumers actually get. Okay, let's take a look at this next example. Numerous studies have linked smoking during pregnancy with health risks for newborn babies. The following table compared the number of cigarettes of different populations of women who smoked during pregnancy. We are interested to see if there's a difference in smoking habits between the four groups. Okay, so we're looking at 1 to 10 cigarettes a day, 10 to 19 cigarettes a day, or more than 20 cigarettes a day. And then over here, we have the various ethnicities of women when they had their children. Okay, now notice we have two different categories, but think about your population here. So is this the same population or different populations? This is different populations. The key here is that there are actually three different populations. We have those that smoked 1 to 10 cigarettes a day, 10 to 19 cigarettes a day, or more than 20 cigarettes a day. So keep in mind that was, as you're reading the question, you want to decide how many populations you have in order to determine if it's a chi-square test for homogeneity or independence. Okay, so what to watch for in deciding whether or not it's homogeneity or independence. Both tests for homogeneity and independence, they have to start with a two-way table of observed counts, the degrees of freedom. You need to include your test statistic and your p-value. All of those are calculated the exact same way. What's different? The questions of the two tests are different, which make the null and alternative different. Remember, a test of homogeneity tests to see whether the distribution of one categorical variable is the same across multiple populations, versus an independence test tests whether two categorical variables are related or associated for one population of interest. If you're unsure on the question, look and see how the data was produced. One random sample, that's independence, or two or more samples, then you know it's homogeneity. Let's take a look at this one. Now notice, with a chi-square test, we can sometimes actually use a 2-sample z-test for proportions. How will we know what that looks like? Shopping at a secondhand store is becoming more popular and has even attracted the attention of business schools. A study of customers' attitudes towards the secondhand stores interviewed separate random samples of shoppers at 2 secondhand stores of the same chain in 2 cities. The two-way table shows the breakdown of respondents by gender. Do the data provide convincing evidence of a difference in the true gender distribution of shoppers at the 2 stores? Okay, so here, notice how many populations do we have? We have city 1 and we have city 2. So that means I have 2 different populations, which means here I can use a chi-square test for homogeneity. Okay, now also, since this is 2 different populations, we can actually use a 2-sample z-test for proportions. Now, what would that look like? How do you know which one to use? Remember, the chi-square tests are always two-sided, so you cannot use a chi-square test for a one-sided alternative hypothesis, because if you take a look at the question, it says, do the data provide convincing evidence of a difference? It doesn't say that one is larger or smaller in the true gender distribution of shoppers at the two stores. Okay, anytime you conduct a chi-square test for a 2x2 table, you can also use a two-sample z-test for proportions. If you're given a two-sample z-test for proportions, you can't always use a chi-square test for a 2x2 table, because remember, it has to be two-sided. So when deciding which test to use, here are some rules to follow. Make sure that you understand the chi-square test is always two-sided. It only tests to see if there's a difference in the proportions. If you want to see if one is larger than the other, you must use a two-sample z-test. If you want to estimate the difference between the two proportions, you have to use a z-interval. So be careful of that wording. If it's asking you to estimate what the difference is, you're using the interval. There are no confidence intervals for chi-square tests. If you're comparing two or more treatments or two or more populations, then you have to use a chi-square test, because the one for proportions only uses two populations. Now, you can also use a chi-square goodness of fit test in place of a one-sample z-test for proportions if the alternative is two-sided. The chi-square test will use two categories, okay, success or failures, and have a degrees of freedom of 2 minus 1 or 1. So here's your section summary. Go ahead, take a minute, read it over, and if you have any questions, let me know.